Hi, Chem students. Welcome to a new unit over bonding. Please have out your notes, something to write with, and maybe even a highlighter. Okay, first we're going to start with reviewing a couple of things from previous units that you really need to know for this unit. First of all, a chemical bond. It's an attractive force that holds two atoms together. We're briefly going to discuss metallic and ionic bonding in this unit, but we're primarily going to focus on covalent bonding. Valence electrons. Hopefully at this point in chemistry you're comfortable with these guys, but we're going to review them anyways. They're the electrons in the outer energy level of an atom. We say they're like the front lines of an army because they're the electrons involved in bonding. So how do we figure out the valence electrons? There are two different ways. So the first way is probably the way you're the most comfortable with. It's by memorizing the pattern on the periodic table. So we know in the hydrogen group that these atoms have one valence electron. Above beryllium, they have two. Boron, 3, carbon, 4, nitrogen, 5, 6, 7, and 8, with the exception of helium, which actually just has 2 valence electrons, but neon and down has 8 valence electrons. It has a full outer shell. So we can just look up the elements and see what column they're in. So magnesium, for example, is going to have 2 valence electrons because it's in the column with beryllium. Oxygen has 6, argon has 8, and silicon has 4. So you can figure out how many valence electrons simply by knowing the pattern on the periodic table. Another way to figure out valence electrons is to use the electron configuration. You can count all the electrons just in the outer energy level. So this is the 1s2, 2s2, 2p6, 3s2, 3p6, etc. That pattern that we learned earlier in the year. Okay, so magnesium, it's located right here. So I'm going to start at the beginning with hydrogen, and its electron configuration is 1s2, 2s2, 2p6, and 3s2. So I'm stopping at 3s2 right where magnesium is. Oxygen, I'm going to go ahead and write its electron configuration. So oxygen is located right here. Again, I'm going to start at hydrogen and write 1s2, 2s2, and 2p4. Okay, so to figure out how many valence electrons there are, we're going to look in the outer energy level. Remember, this number is the energy level. The number of electrons in that energy level is the coefficient. So in magnesium, we have 2 valence electrons, and in oxygen, we have to add together the exponents, and so we have 6 valence electrons. Moving on to metallic bonds. So in a metal, the valence electrons are not held tightly by the nuclei. They're delocalized and are therefore free to move around through the lattice of metal atoms. This is called the electron C model. Metallic bonding refers to the attraction between the metal nuclei and the sea of electrons surrounding them. Okay, so for example, these could be copper atoms. So we would have 1, 2, 3, 4, 5, 6 copper atoms, and they have to be bonded to each other to make a sheet of copper, for example. So the way that they're bonded is through metallic bonding, and this is different than the other two types of bonding that we'll learn about. It's very unique in the fact that the valence electrons of these atoms are kind of shared among them. So these guys are delocalized, meaning they're not held by the atom they belong to. They're kind of free to move around between the different atoms, which causes them to be bonded or associated with each other. So they just move around freely and are shared by these atoms. The following properties of metals can be explained by the freely moving electrons of the electron C model. So these metals, because of their metallic bonding, are good conductors of heat and electricity. They have high melting and boiling points. They're strong. They're malleable, which means they're able to be hammered into a sheet. Ductile, which means they're able to be drawn into wire. lustrous, meaning they're shiny, and opaque, meaning they reflect light. So words like malleable, ductile, lustrous, and opaque, you actually do need to know what that means. So maybe submit that to your vocabulary list of things you need to know for this unit. Okay, so that concludes today's video over metallic bonding and a review of valence electrons. You're going to move on next to our penny lab so that you can see metallic bonding in action. I hope you enjoyed today's lesson. Feel free to rewatch the video or ask your teacher for more help in class. Have a wonderful day.